Okay, so the last part of sinusoidal, right? It's the last lesson, and it's the fourth and final. Tomorrow we'll do a bit on puzzles, and then you can also work on sinusoidal. Friday will be the review for sinusoidal. I'll get you some stuff, review sheets and that by Friday, maybe by Thursday. And then Monday will be the test. So what we're going to do is we've got on the screen, we've got the average temperatures for Calgary, average daily temperature for each month. And it's average, average high, average low. We've decided we're going to graph the average temperature for the month. So basically what they're going to do is they're going to take the average temperature for each day in January, add them all up, and then average them to get an average temperature for January, which is negative 8.9 degrees. And then February, negative 6.1, March, negative 1, and so on. Okay? So in order to graph that, we know that we've got 12 months. We're going to use January as month 1, and February is month 2, and so on, right? Because after we're done this, we're going to draw this ourselves, see what we come up with, and then we're going to run a regression on the calculator to see what it comes up with, okay? Just to give us an idea of what's going on. So we decided, let's turn the paper this way, and we will start the scale here, and we'll just label 1 through 12 along here. And we've got degrees, so we need to say what's the lowest of the average temperatures. This is not hard. In the chart, what's the lowest temperature? What's the number? Negative 8.9. What's the highest? 16.2. Okay. Now we know it gets hotter than that in July. You can see the average high temperature in July is 22.9, but we're doing average. So we need to go from at least negative 9 to say 17, right, to cover off the whole range, which is 26. We don't quite have 26 here, right? So we're probably going to go by about 2 degrees. Okay. So we'll make our scale along the horizontal axis 2, so we can sort of do a little scale break thing. And I'll show you what I mean by that when I figure out where the stuff is. And I don't have 12 across here, right? So I'm just going to fake it. So I'm going to say, okay, that's 1, 3, 5, 7, 9, 11, and 12. So my other ones will be by 2s. And these guys, what I'm going to do is put a little scale break in here, just to show that we're not starting at 0 or something like that, right? I'm going to go negative 10, negative 8, negative 6, negative 4. So we'll go by 2 degrees, right? And then we should be able to fit everything in. And for me to fit stuff in on here, I'm going to go by 4s. You sit up front, you get delivery otherwise. Thank you. Okay, and what we're going to do is we're going to plot points, right? So we're going to take the temperature for January, which was negative 8.9, right? And we're going to graph that on our graph, okay? And you come as close as you can, right? I mean, obviously, this is not going to be exact. So 1 was negative 8.9, so there's my point. And let's go back to the chart, and you can graph the rest. So 2 is negative 6.1. Right, so we're representing January as month 1, 2, 3, 4, 5, 6, 7, 8. And we're going to plot these 12 points, right? So negative 6.1, negative 1.9. And I'm going to plot, so I got to jump back and forth. Negative 6.1, negative 1.9. 4.6, 9.8, 13.8, 4.6, 9.8, 13.8. Whoops. So grab a few numbers and 16.2, 15.6, 16.2, 15.6, 10.8, 5.4, 10.8. Wow, really cools down from September to October, right? 5.4. Negative 3.1. And negative 7.4. Negative. Okay, so we'll go back here so you can finish it off. Okay, so everybody got the plot done, or points? Right, so we can lose the chart now. For now. We're going to come back to this in a minute, right? Because we're going to do this on our calculator, so. Okay, so we've graphed the points. You could just go 1, 2, 3, 4. It says we're 12 over here, but it's okay. It's all right. You're still laughing. That's good. I saw that. We'll get you your scholarship. You just gotta do a little work. Okay. Got them all done? Oh, come on. I got them all done. I was flipping back and forth.
So we could see.
Yes, and now I've given you about the amount of time that I spent. Okay, finish off. What we're doing is we're graphing. I'll show you Jen. Okay, you done?
Yes.
All right, good, because otherwise I'd have to pause it. It's just too long. Okay, so we got something that looks like this, right? What are we going to do with these points? We're going to draw a nice, smooth sinusoidal curve, right? Is this data sinusoidal? It's the first question, right? Does it fit what we know to be a sinusoidal pattern? Yeah. Does that make sense? Yeah, because we know, we've lived in Calgary long enough, we know the temperatures, and this is what they do. Okay, so right, and then we know that this is going to continue on in both directions, right? So what we're going to do in a moment is we're going to come up with our own equation based on this, right? We're going to figure out values for A, B, C, and D, and come up with a sinusoidal equation. Okay, which we should be able to do, right? We've got a nice graph. This is from a graph to an equation. Okay, so when we do this, what do we need, right? We need the max and the min. So what are we going to take as the maximum temperature? So forget the table. Let's just go from what we see here. So what's the max? And I want to go from your data because your graph's a little more accurate than mine. I had to sort of squeeze it in. What's the max? 16.4. What's the minimum? -9. Okay, we got a max, we got a min. What do we do with max and min? Well, what can we get, right? So we can get D, right? D is max plus min over 2. So 16.4 plus -9. Which is equal to 3.7? Or not? Yeah? Okay, 3.7. Okay, what do I want to do with that 3.7? I want to graph it, right? I always like to see my midline. Right? So this is the line y equals 3.7, right? That's the equation of the midline, also known as the median. I was just reading the curriculum again. They said make sure that they understand median and midline are kind of the same thing, right? And really here, it's the median because it's the median temperature. So guess what? The average temperature in Calgary year-round is 3.7 degrees Celsius. You know, like, why do we live here? I mean, 3.7 degrees. It's just like, why are you here? You could have been somewhere warm, you know. But, okay, so the average temperature. Now, this is what we're getting from this, right? Now, what's the amplitude? Well, we know that A is max minus min over 2. Right? We can also just say, well, 3.7 to 16.4 is how much? Right? That's another way to get amplitude, but we might as well calculate it out. Let's use the formula. Remember, you don't get these formulas, so you got to know this until June 25th at noon, at which point you don't have to know this. Right? But, you know, you just do a few problems with it. It's not a big deal, right? You'll figure it out. So what do we got? 16.4 minus negative 9 over 2. So what's that? 25.4 divided by 2. So 12.7. Okay, so the amplitude is 12.7, right? That means we vary 12.7 degrees. Remember, put this in the context. This is what we did yesterday. So we're putting this in the context of the problem, or the data, right? And so the data says, hey, we have an average year-round temperature in Calgary of 3.7 degrees. We vary 12.7 degrees from that to a maximum of 16.4 degrees and to a minimum of negative 9 degrees. All right, what else do we need to know? What's the period? Don't go in months. What's the period? 12. Don't even look at the graph, right? It's a yearly thing, so, right? Don't, you know, we got to go from low to low or high to high or, you know, whatever. We could count sort of from here, you know, like let's count from midline to midline, right? So this is like month 4, and this is like month 10, about, right? Which means half the period is 6 months, so what's the whole period? 12 months, right? What's the minimum that we would need to see on the graph in order to figure out the period? How many months? Would you need to see? Like if I cut off part of the graph, how, you know, and didn't tell you what it was, so I didn't put context on it, but said, hey, you can see, you know, how much of this would you need to see in order to be able to figure out the period? 1/4 of it, right? So if we could see, say, from here to here, so if I knew that the distance from the midline to the max was 3 months, then I say, hey, I've got 1/4 of the period. Remember, I told the sine function split into 4 parts, right? From the midline, well, in this case, from the minimum to the midline, from the midline to the maximum, from the maximum to the midline, and from the midline to the minimum is 4 parts. As long as you can see 1/4, right? As long as you've got at least one of those chunks, then you can figure out the period. That was actually a question in the the standards document for this course. They said, you know, they marked them A, B, C, D, and E, and said Mary said she could figure out the period because she knew these points, and then Billy said he could figure out the period because he knew those points. Explain why they're both right. Okay, and so it's just you need that conceptual knowledge of, hey, if I could see half the period, I just have to double it. If I can see 1/4 of the period, I'll multiply it by 4. All right, so the period is 12 months. Run out of space. Period equals 12 months. So what's B? So we got a formula, right? Period equals 2 pi over B. That's our formula. That can be rearranged. I'm going to go up here. So B is equal to 2 pi over the period. So So b is equal to 2 pi over 12, which is pi over 6. And we're just going to leave it in terms of pi, right? Because that's exact. Pi over 6 is exact. Anything else is just an estimate. And when you plug it into your calculator as pi over 6, it's immediately going to switch it to a number. And what's left? Start point, right? Start point. So where does it start? We seem to reach our median temperature by this graph. Now, does yours agree? I mean, because remember, mine doesn't have quite the same scale. Do we reach our midline at about 4, or where do you have it on yours? Less than 4? 3 point? 3 point? I don't know. So you got 4? 3.7? You got 4? What are we going to go with? We need a number. 3.7. 3.7 is the temperature, so you're saying 3. All right, so we'll call this 3.7, 3.7. This is our start point. So start point is where the curve intersects the midline and it's going up. So when that first happens, right? All right, so we're using 3.7. The start point formula I gave you was it's negative c over b comma d, right? This we already have. We already know d is 3.7. We are going to work out c, right? Because I want to be able to graph this on a graphing calculator, look at it. So I want to get the full equation, right? So to get the full equation, so we're going to say negative c over b is equal to 3.7, right? This 3.7, not that 3.7, right? The x value. So negative c is equal to 3.7 times b, and c will equal negative 3.7b, which is negative 3.7 pi over 6, right? It's just negative 3.7 times that. So I'm doing that so that we can enter this into our calculator and just see, hey, did we actually get the right equation, right? Because you're going to do this on Monday, right? I'm going to give you a graph and say, determine the equation, right? Show me all the work. And you're going to do stuff like mark on here max and min, and then go right max plus min over 2 gets my d value. Max minus min over 2 gets me the a value. You're going to mark off on here and say the period is, period is 12 months. You're then going to calculate the b value from the period. Okay? You're then going to find the start point because you're going to draw your midline. That's why we always draw a midline. You're going to find the start point and you can do a little magic, also known as algebra, right, to calculate the value of c. Then you're going to plug that into your graphing calculator, set the window to this, and say, yeah, I got it right. If you get it wrong, you're going to go on and finish the test and then come back and figure out what was wrong. Okay? But don't spend a lot of time on that particular problem at that time, right? If you get it wrong, just leave. You've still got some marks that are sitting there. You may just have one thing figured out wrong. Okay, let's open up a calculator and, let's write it out and then we'll open up a calculator and plug it in. Okay, I got no space. Y is equal to A, 12.7. Sine, bracket, B, pi over 6. X minus, actually it's going to be plus, it's minus 3.7 pi over 6 minus 3.7 pi over 6, bracket, and what's D? Plus 3.7. Okay, I'm going to pause. We're going to calculate. Y equals, so 12.7, L1, nice. 12.7 sine, mode, radians, just checking, make sure I'm in radian mode. 12.7 sine pi divided by 6x minus 3.7 pi divided by 6, close bracket, plus 3.7. I also like to graph midlines, so I'm going to go y2 equals 3.7. Let's go set our window. So we're going from 1 to 12. Actually, let's go 0 to 12. By ones, and what do we say, negative 10 to, I've got like 18 by twos, and the moment of truth. Okay, so does that look like? Hold on. You're supposed to express the answer. Or just give me the value. Look like that? Yeah, pretty close. Okay, so we did a good job then, right? So where do we go from here? So we have a model, right? Wow, I see all this. Wow. We have a model, and we have two that just joined us. We have a model of a sinusoidal function. Well, no models get to sleep in. So we have a model of a sinusoidal function based on some real life data, right? We did it by graphing a scatter plot, finding the max and the min, using that to get the D value and the A value. We found the period from the graph. We used that to get the B value. And we found the starting point of the graph by finding where the graph intersects the midline and the graph is going up. And we used that to calculate the C value. We then took the A, B, C, D, wrote an actual equation, and we can use these numbers to describe things, right? The average temperature in Calgary over the year is 3.7 degrees. It varies by 12.7 degrees, higher or lower, to a maximum of 16.4 and a minimum of -9. What else? Not much else to say, right? I mean, just that it starts, we first hit the midline. So we first hit average temperature in late March, right? 3.7 is, 0.7 of the way through March. After which we stay above the average temperature until we hit, here and so on. Right. That's me asking you to do it, here, graph this and then figure everything out. Your calculator can also do this. So let's go into our calculator. I'm going to go back to y equals. I'm going to clear everything out. And I'm going to go second mem, number 4, clear all lists. Okay, so you just joined us. You can do this part. So we now have a clear calculator in radian mode. Right, so make sure that it's in radians. You have to be in radian mode to do a sine regression. We're going to go to Stat, Edit, and we are going to put in this data, right? This data. So in L1, we're putting in the number of the month. January is 1 and so on, right? So this is going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and I'm going to double check these, right? Anytime you run a regression on a test or anything, just double check you've got the numbers entered correctly. Because if you enter them wrong, your answer's wrong. If it's numeric response, you're just going to be wrong. You have no way of knowing. If it's multiple choice, you at least have a shot because you probably won't get the answers they have. Okay, L2, we're going to put in, get your calculator over. L2, we're going to put in the temperatures. Okay, so negative 8.9, negative 6.1, and so on. 4.6, 9.8, 16.2, 15.6. 4, negative 3.4, negative 7. Okay, and I'm going to go back through the list and just verify my numbers. So I'm just going to go up. I'm going to look down here. If you look down here, it's easier to see the number. And you can say, okay, so 12, I should have a negative 7.4, negative 3.1, 5.4, 10.8, 15.6, 16, 9.6. All right. So we've made sure, right? You want to double check, make sure that everything is good, okay? Because if you're running a regression, there's no room for error, right? especially on numeric response, because it just is what it is, and it's rounded to the nearest tenth, and if you have any one of these out by even a tenth, it'll throw your regression equation out. Okay, ready to regress? Stat, over to calc. Up arrow, because sine reg is at the very bottom of the list. We're going to run a sine regression. We hit enter. We want to put it into y1, so we hit the vars key, we arrow over to y vars, we hit enter twice. So this is what should be sitting in our calculator, right? Sine reg y1. You don't have to put in L1, L2. If you're using one of the newer calculators, it'll say sine reg and then it'll have L1, L2. And where do you want to put it? Okay, so you could just leave that, that's fine. So it's defaulting to L1, L2, right? It says your x values are in L1, your y values are in L2. We're going to hit enter. It's going to come up with an equation. I wonder how close we were. I mean, the 12.7 is like pretty much bang on, right? Do we have 12.7? So we have 12.7. So this is how you're going to write it. You're not going to write this down. Do not do a screen dump. I'm not interested in, yeah, you can copy the screen down. I will give you no marks for that, right? We're going to, let's say we round to, so we're going to write it as y equals 12.72. We'll go 2 decimal places. Sine 0.51 x minus 1.98 plus 3.65. Okay, that's what you're going to write for any regression equation, right? You write it out just not, you write it out in the proper form. You write it out like this line up here, only you put the A, B, C, D in, you put the actual values in. Round it to whatever we ask you to round to, right? Nearest tenth, hundredth, thousandth, whatever. Now, pick graph. Oh, actually, sorry, we should turn on the stat plot too. I'm going to go second y equals and turn on stat plot 1. Okay, that'll just graph our points, right? That's our scatter plot because we want to see how well do we fit. How well does it fit? That's pretty darn close, eh? I'm impressed. I didn't do this beforehand, right? Because I asked you which temperature did you want to use, average, high, or low. I hadn't done that, but there you go. So we have a pretty good model of Calgary temperatures here, right? This one is probably a little more accurate than what we came up with, although I recognize some of the numbers, so I think we were reasonably close actually, which impresses me even more. We'd have to work out the B and the C values though, right? Because we had them in terms of pi. So hang on, I'm just going to write this on the board. Y equals 12.72 sine 0.51x minus 1.98 plus 3.65. Okay, I just want to compare that to what we had. We can answer questions using this, right? So what are the questions? Well, what's the temperature, what's the average temperature in August? We know what the table says. We're going to go second calc, put in a value for August of 8. And you notice that we aren't exactly on, right? That the value in the table is 15.6. The value the model's giving us is 14.8, right? Because it's not an exact fit, right? I mean, we know temperatures vary year to year over time, and this is sort of a long time average. You know, maybe things have warmed up in the last 10 years. Maybe if we had a 10-year average, it would look a little different. It might be more accurate to today's temperatures. Another question I asked, so what's the, you know, you've got a function going on July 15th. What do you expect the temperature to be on July 15th? What are we going to have to do here? So, when is July 15th? Let's go 7.5. It's about halfway through July, right? So July is month 7. 15th is about halfway through July. So we'll say 7.5. Remember, X is in months, right? So about 16 degrees, right? We expect it to be about 16 degrees. Anybody know when the growing season starts? What is the temp? Oh, we'll do this one. The temperature to change from winter tires to summer tires should be 7 degrees Celsius or above, right? So you want an average daily temperature of 7 degrees Celsius, because my car has pure summer tires, not all seasons. If it's much colder than 7, it's like driving around on slick, like they slide out when you don't want them to. So we need a 7 degrees Celsius. So for me, an actual useful thing for this is to go in and graph y2 is 7. So I want to know, when can I when can I put the summer tires on the car, and when do I take them off the car? Okay? So let's run second calc, intersect, and I want to find when, 1, 2, 3. So 4.44 is when we will first hit 7 degrees, and intersect again. I'm just going to trace along the straight line because it's faster. And 1, 2, 3. 9.59. Okay. So if I want to convert those to days, right? Month 4 is April, right? January, February, March, April. 0.44, there's like 30 days in April. 0.4 of that, let's call it 0.5. So about April 15th. So mid-April is about the earliest that I should think about changing over to my summer tires. I'm likely to do it like Victoria Day weekend, actually, because I don't trust the weather in Calgary. And then 9.59 is when I should be changing from summer tires back to winter tires. So 9 is September, 0.6, about 30 days in September, so about the 18th of September. Usually I let it go a little bit longer than that, but I should be thinking of changing tires out back to winter tires about halfway through September. So what do I get? Mid-April, May, June, July, August. I get about 5 months maybe of summer tire wear. Okay, anything else we can do with this? Right. Again, we can just take the regression equation and analyze, right? There's an average temperature of 3.65 in Calgary, varying by 12.72 degrees. So if I want the max, what do I do? It's Monday, you got this sitting in front of you. I'm saying, what's the maximum temperature in Calgary? What do you do? Yeah, you add these two numbers, right? It's the midline plus the amplitude. What do you do to get the minimum? Take the midline, subtract the amplitude. Hope you're better at this on Monday. It could be rather depressing tomorrow. Right? Don't make my Monday night depressing. I want to sit there and go, yeah, please get this stuff right. Period. So let's just click out of here. What's 2 pi divided by 0.51? 12.3. Okay. Now again, we rounded that, right? If we took the actual value, it should come out to 12 or pretty close. Start point is negative c over b. That'll be 1.98 divided by 0.51, which is 3.88, right? And we figured what? We had 3.7, right? We're pretty close. So this value here, the start point from this equation, the period was 12.3, and the start point was 3.88 and 3.65. Okay, let's just click back over to the notebook file. So what's pi over 6, right? Because pi over 6, because in this equation we had this as 0.51. So second pi divided by 6, 0.52, right? It's okay. So pretty close, right? We're pretty close. What's 3.7 pi over 6? 3.7 pi divided by 6. So in our equation here we had 1.98 and we had 1.94. We had 3.7, it's 3.65. We had 12.7, it's 12.72. So I think we did a pretty good job coming up with the regression equation by plotting the points, drawing a sine function, and just analyzing it that way, right? That was pretty good. But now we also know how to do it using the calculator, right? So entering your x values into L1, y values into L2, running that sine reg, so stat calc, and just up arrow because it's the bottom sine reg, and telling it to put the stuff into y1, so vars, y vars, enter, and running the sine regression, right? Show your stat plot so you can see the points, because you want to know, did this really fit? Maybe it doesn't fit, right? Or maybe you just, whoa, this doesn't even fit at all, okay? So, you know, when you graph it, graph the points and then graph the plot and say, hey, does this fit? Okay, and I always like to graph the midline, just say, does it look like it's in the right place?